All right, can people hear me? Can people hear me? Let me know. That'd be great to know that y'all can hear me before we kick it off. Do let me know. All right, I see Etor Nam is here. All right, thank you. Thank you for letting me know. Lyndon Smith, thank you for that confirmation. Thank you. And all right, it's 4:30 my time, so it's UTC 12:30. I mean 20:30. Beginning of World Quant 1 office hours. We are in week 5, right? Week 5, 3 more weeks to go. Last office hour of the week. Hope everyone is doing fine today. With that said, let me show you what's on the agenda, which is continually to progress through the DW mini project. We'll continue to make a headway there. Thank you, Esther, for that confirmation. We'll continue to make headway on the DW mini project. And as we go through, we'll also have kind of like mini lectures of some of the things about pandas. So let's also not only know how to solve this mini project, but get a good comfort level, get very comfortable, get a knowledge of understanding with working with these methods and calls, these tools provided in pandas. So a dual approach there. All right, so let's go ahead and see. Okay, all right, I see Pulkit is here. I see Paulo is here. Hello, hope you are doing fine today. Let me know anything else to throw on the agenda, any questions you guys have today. Do let me know so I can put that in the agenda. One of the things we're going to do is after we are done with this mini project, we're going to take what we have and package it together. And write a command line tool for us to repeat this analysis but on different data sets. So that'll be in the motivation, sort of a good way to kick off, good way to end our last mini project, to encapsulate this so we can repeat this analysis on different data sets and perhaps find a motivation of why we want to do this. Understand the motivation, understand what we want out of it, so we build this tool, which will give us a good foundation when we start working on those additional topics like Flask, like version control, like web applications. So we build upon, so we can use that as a first step as we work together to work on a project together towards the last couple of weeks of this unit. Right, we're almost done with the unit, for better for worse. So I do encourage you guys to wrap up all your work so you can apply to Unit 2. Don't forget the applications are open for Unit 2. Make sure you sign in to the same login that you use to apply to the program. We ask you to do that because that is the way we keep track of who is who. So if you do it correctly, when you apply, you should see 2 boxes, one for Unit 1 and one for Unit 2. So do make sure you see the Unit 2 box and you do check off the Unit 2 box. You want to make sure that you apply for Unit 2 and not for Unit 1 again. So do make sure you carefully see that there's a Unit 2 box and you check it off. So we want to see you guys in the next year for Unit 2, where we learn about machine learning. Okay, I see Kinjal is here. Hello, Kinjal. I see that Shakiba is here. Hello, Shakiba. Let me know any additional topics to throw on the board before we begin today. All right, someone is saying I use an inefficient method to get the results of DWQ1, and the answer is right, but the grader gave me 0. Is the grader able to determine the process for obtaining this solution? No, the answer is the grader has no way of knowing how you obtain the solution. The way the grader works is here you are. You make a grader submission when you run the grader cell. What you do is you call upon a server. I'll draw the grader server right here. And when you call it, you pass the name of the question. So here the server, the grader server, takes the name of the question. And it says, okay, it returns a test set. Now, not all questions have a test set. Some questions do not have a test set. And then what it does, it takes your answer, and if it's a function, it calls that function on the test set. If your answer is a static answer, in other words, it's not a function, it's maybe a list, then what you do is you pass that list to the server. The server looks at your answer, looks at the correct answer, gives you an evaluation, and passes that evaluation back to you, and it writes to a database, an SQL database, which we'll see some lectures on next week, I believe, or 2 weeks from now, and it records your grade. So because of that, the grader has no idea how you obtain the solution. So if you are getting 0, that means that it's not because it knows how you came with the solution and penalized you. So do make sure that you perhaps are, that you have it set up. One thing that happens, that could happen, and this has happened to me, so it happens to everyone, is where you define your answer, but notice the grader cell is already set up for an answer. And sometimes we have a default answer, right? We have a default answer, and you call the grader with the default answer. So maybe that's what happened. Maybe you forgot to, you ran this cell, it overrode your answer, and you're passing the grader this default answer. That's a common mistake. Do check upon that. It does happen. It happens to everyone. That does happen to me. So do make sure you correct that. I'm just running cells here just to get ready where we left off yesterday. So that's what I'm doing right now. Let me take a look at the chat. I see that that Madiha is here. Hello. Open Yemi is here. Hello. I see Tom and Mr. Wiki is here. Hello, guys. Welcome to Office Hours. Torna, hopefully that solves your question. But if you do figure out what happened, do let us know so we can keep track of that. Be aware of what other issues might come up. All right. We'll go ahead and kick it off with the DW mini project, but do let me know anything else comes up you want me to talk about. So let's go ahead and kick it off where we left off yesterday, or yeah, it was yesterday. Well, we had these two data sets, and we decided to merge them together. So now when we examine the data, we have the postcode information for the practice that signed that prescription. All right, so we're almost there. So the next thing we got to do is, well, if I look at here in my roadmap, is I want to calculate the sum of the items for each BNF name and for each postal code. So every time you find yourself, I want to do X on Y and Z, that means you need to group by Y and Z. So that's what we're going to go ahead and do. I create a new cell right here, and I say scripts with postcode, and I'm going to say group by postcode and BNF name. And then I want to index items, since that's what I want to calculate, and calculate the sum. So now let's go and run this here. So observe the results. So this is what I have here. I have postcode, BNF name. So the sum of items for each postal code and for each BNF name. Now I'm going to go ahead and, one thing we're going to do is I'm going to reset the index. Let's see if that's okay. Just making sure if that gets what I want. All right. So this here returns a series. In fact, I can verify myself that it's a series. And there it is. It's a Panda series. However, notice I have two set of indices. A series is just a column, but here we have two indices for each row, postcode and BNF name. And what I want to do is I want to take those indices and make them columns in my result. I want to make sure that postcode and BNF name are columns to my result. So what I'm going to do is I'm going to reset the index. So every time you say reset index, what happens, it takes the indices the indices of our result and make some columns to our result. So if I run this here, what I see is now I have a column called postcode and a column called BNF name and a column called items, which is the sum of the items. And of course, I'm going to assign this to an output. So I say output equals scripts.groupby, these two fields, index sum, so items, calculate the sum, and reset the index. And I'll go ahead and have output head right there. So now I'm almost there, right? I have the numerator. This right here is going to be the numerator for what I'm trying to calculate. All right, let me know if there are any questions right here. Keep in mind I am chaining method calls, and I'm able to do this because things like reset index returns a data frame. Okay, let me take a look at the chat in the meantime. All right, someone's saying I was doing this yesterday and my kernel was dying and restarting. Somehow today it worked fine. Yeah, I'm not quite sure what is happening there. Maybe you had another notebook running, because if you have another notebook running, that's a competing resource. And since we have to serve thousands of students, the memory in your systems, in your servers, isn't that high. I believe it's 1 gigabyte. So because of that, it really your kernel may die. So do make sure that you don't have other notebooks up and running, because it can your kernel can die and crash. The other thing you could do is maybe you have variables you're not going to make use of anymore. Maybe you create some results before that you don't need anymore. You can always delete those. You can always say del in the variable name. This might be great if you've done with that object, you don't need it anymore, you got to delete it. You can say del the object name, and that will delete that object. So if you're running into kernel issues, do keep an eye on that. Where are things you can delete to conserve your memory, conserve your computer's memory? All right, so let me know if there's any follow-ups here before we take a look at how to calculate the numerator. The denominator. Okay. Let me know if questions come up. But now I want to calculate what's going to be the denominator. So what I got to do is remember, just like we did in the previous one, this ratio, or we can say numerator over my denominator. And my numerator is the total, the sum of the max items. The denominator is the sum of all items in a given postal code. And I've calculated the numerator right here. So now I got to calculate the sum of items for every postal code. So notice what I'm saying. I got to do X for every Y. So that means I need to group by Y and perform X. So that's what I'll do right here. In fact, I can work on this output data frame. This data frame I call output. I can group by now just my postcode, index items, and calculate sum. And I'm going to call this total. And then let's call total head to see the first 5 results. And that's what I do there, and sure enough, what I see here is the total, what appears to be a value for every postcode. So now what I got, what I have, someone said helps to sketch this out, and looks like my mouse died. Unfortunately, my mouse died. I gotta get a new mouse. Sometimes the buttons don't always work. Let me go ahead and see if I can try to revive this mouse. got a rechargeable battery, but it doesn't tell you when the battery is low. Oh well, I'm gonna have to use my trackpad to draw these diagrams, so bear with me. All right. So what I have here is I have this data frame where one of the columns is the numerator. Right. I can draw, but I can't really write. And I have here is a column of the denominators. A column of the denominators. Oof, I really can't write with the trackpad. All right, let me go ahead and charge my mouse in the meantime. So hopefully maybe in 5 minutes it has enough juice for the rest of office hours. So hold on. All right, so we got to bring in this column for this data frame. Now, one of the things to keep in mind is I know how to add a column to a data frame. We've seen that syntax. It's very much like the key, creating a new key value pair in a dictionary. So for example, if I say, what do I call it, output, and I can create a new key value pair, and I can say total to represent what would be the denominator, and I say equal to total, right? This resembles the key value pair creation, right? Resembles creating a new key value pair of a dictionary. Okay, and let's try this. Let's see what happens. All right, I'll create the new column, and then I can look at the result, and let's see what happens. Let's see what happens there. And what I have is NaNs. Why am I missing all these values? I thought I added this column to the data frame using the key value pair syntax we're used to with dictionaries. But if I look at this, I don't have that. I see total is there, but I see nothing but NaNs. And I know how to check for NaNs. I can say index that column. I can say the is null. This here returns a Boolean value, whether we have a null value, an NaN, and not a number. And they seem to be all true. And I can even do something like output and select all the rows of my data frame where I don't have a missing value. So I can go ahead and invert this here. And it looks like there is no row that has a valid value. I thought I added that column there. Why don't I see those numbers? Why do I have nothing but NaNs and doesn't appear to be any row in which total has a valid value? What do you think happened here? What did I do wrong here? Let me know, and I'll take a look at the chat right here. All right, I see Kinjal saying that the amounts are different from mine, and that's interesting. Okay, I guess I see what you're doing. You're showing some of your results, and they're slightly different, off by a fraction. I'm not sure what that could be. I think it should not affect your answers. It should not affect the final answer, and the reason why is because a grader uses a tolerance. If your answer is off within a certain tolerance from what the grader uses, it's going to give you the full credit. So I don't think it should matter. I'm not sure where's the issue coming from, but if you do get less than, let's say 0.9 we can try to revisit and see where that's going wrong. But I think it should be enough for you to get a good score here. All right, so I see some suggestions of figuring what's coming on. Maybe the values are strings. Maybe that's what's going on. The row indices of total don't match up with the data frame. Yes, that is correct. When I create a new column of the data frame, what happens is that it looks at the series and says, okay, what is your index? And let me see where should I add you in the data frame. When I do this here is going to add those new records, add those new values based on matching row label. It's not going to do so by position. It's not going to do so by position because Pandas doesn't really like to work with position. It likes to work with row labels, column labels. That is why we don't say, give me column number 5. I say, give me column BNF name. And in fact, right, we see that total, the indices are the post code. But in this data frame, the indices seem to be 0 index. So that is a problem. So let's see how we can fix that. So I'm going to go ahead and recreate this data frame right here. But what I'm going to do is I'm going to say set index. Let's say set index. I'm going to break this down into multiple lines. Just so it can be hopefully a bit more readable. I'm going to say set index. I'm going to say post code. So now post code is an index. So then I calculate total, and then I'm ready to add those key value pairs. So now let's see. Now let's go and check it out. Let's see what happens now. Output head. That seems to have worked out. Now I have the appropriate. Now they're in there correctly. In fact, let's see if we have any records with no values. Let's see. There are no records with no values. So now that we've added this column, then we are ready to create a new column that's the ratio. So I can say output. I want to create a new key value pair, and I'll create that column called ratio. That's its name. That's what I'm going to call it. And it's going to be equal to output. And let me just turn off my notifications on my computer. Give me a sec so they don't come in. Okay. And this column output is the division of total, the column called total, and the column called items. Actually, it's flipped, right? Sorry. Items is the numerator, total is the denominator. And I can do operations on series. And when I do operations on series, it does so by matching row label. So I have comfort, and when I perform this operation, that when it does items, it's going to divide by its appropriate value of total by matching row label. So that's what I'll do right there. I create the new column called ratio. Let's examine that. Take the head, and sure enough, looks like I've calculated that ratio. Looks like I've calculated that ratio. I'm not quite done yet, but I'm almost there. Do let me know if there's any follow-ups. All right. Do let me know if they come up, but let's go ahead and march on. All right, so now we're not quite done. What I want to do is I want to figure out what is the record for each postcode with the greatest ratio. And we're going to do this via two steps. Okay. So what I could do, so in other words, to recap, is now that I have to calculate the ratios, I want to figure out for each postal code what is the record, because I want the BNF name and the ratio that had the greatest value of the ratio. So if I take my data frame and I say max, I say ratio max, will that give me the max ratio of the entire data frame? Not for each postal code, but for the entire data frame. Further, I can say IDX max, and this will give me the row label that had the greatest ratio. And that's not also great as well. So since I'm trying to do something, for every group, what I should do is I should group by postal code. I want to figure out, I want the row with the greatest ratio for every postcode. So that means I should group by postcode. And then what I gotta do is, okay, what do I do next? Well, let's go ahead and use the apply method. And the apply method is a very versatile and powerful method in Pandas. And it works differently depending on what we're working on. If we use the apply method on a group by object, and this is a group by object since we call group by, then what happens is, well, when we use the apply method, it takes that function and it's going to apply it to every single group in the data frame. And you can think of each group as a mini data frame. Here is a data frame that have all the records for a given postal code. Here is another data frame that share all the same postcode. And we want to apply a given function to each of those groups. So what we should do is, let's see if we can craft our strategy. And when we do this, let's ask ourselves is, how do we figure out the record, the row? How do I get the row of all my entire data frame? Let's just worry about the entire data frame first. Is how do we figure out, how do we get the row that had the greatest ratio value of the entire data frame? Well, I could sort by values and sort by ratio. And by default, this does it by ascending order. Notice the smallest one's at the top. So I can always use a keyword argument, ascending equals false. And then what I can do next is, well, now that I've sorted my data frame, how can I easily get the record with the top ratio? So yeah, we can't simply sort values because that would do for the entire data frame, but let's craft our strategy for the entire data frame, and then we'll apply that strategy across all the groups. That is my motivation here. So now my question to you is, now that I have a result that's sorted by ratio, how do I get that top row? Any suggestions on how can I get that top row? We can use lock, but it's better in this case that we use what instead. Now that I've imposed an order to it, I imposed a position. iloc, exactly, iloc 0. And this will give me the record with the greatest value of ratio. However, this was done on the entire data frame. And I don't want that. I want to do this, but for every group. But the reason why I did this here is I can craft my strategy. Now I have my strategy. Exactly, iloc. Yep, iloc. So you can think of is I can define a function that will take a data frame, sort by ratio, and then return iloc of 0. And I want to use that function on every single group that is created when I group by my data frame by postcode. And every time you find yourself, I have a function and I want to use it for every single group, think of using the apply method of a group by object. So we group by postcode, then we say apply. And apply takes a function. It says, hey, give me a function, and I will apply it, use it on every single group. And the function is, well, we crafted out just above. It's going to be applied to every group, and you can think of a group as a data frame. So I say lambda df. It's arbitrary, but it's best to use readable variables. So I'm going to use df to tell me that, yes, it's a data frame. And then I can say sort values by the ratio, set ascending equals false, and then say iloc of 0. And now I think this works out. I can call this result, and I can say result.head. And notice that this answer, this top answer here, matches with the sample answer of the grader. So maybe I have the correct answer. So let me know any questions right here. There's a better way to do this, by the way. We're going to show you that other way. I think it's slightly better, but one of the things I want to do here is show different ways to solve our questions, the deviations that can happen. Let me know any questions about this approach here. Okay, someone's saying they did not understand this one. Okay. So let's go ahead and maybe take it from the top. How about that? So what I have here, why are you only locating the first one? The reason I'm only locating the first one is because what I want is I want to have the record for each postcode with the greatest ratio value. And I want the entire row because I want the BNF name, the postcode, and the ratio. Okay, you got it? Okay, that's glad to hear. Let me know anyone else who has any questions here. And basically I did it for here. I practiced on how I would do this on the entire data frame, but I want to do this for every group. So I group by, use the apply, and I have that same functionality that I sketched up right there. I have my result. But we'll see a different way to go about this, a slightly different way. I want to show you both methods. And you might have thought this here is a bit cumbersome. All right, so I see some question coming in here. I have a question, please. How does this approach account for different BNF names with the same ratio? What happens to be the max? So different BNF names with the same ratio. All right, so different BNF names with the same ratio. And it does not. However, what I could do is I can sort by ratio and I can sort by a different field. I can sort by, let's say, BNF name. I get a syntax error because when I have to pass it a list, I believe, a list of those fields. And I got a syntax error because, there we go. So I could add an additional field to be the tiebreaker. So yes, good question. I can sort values by BNF name. And I have to sneeze, so hold on. Sorry about that. All right, let's take a look at other things in the chat. Can you identify the max without sorting? And yes, you can identify the max without sorting, which I will show right now. So this here was a bit cumbersome. It's readable, but a bit, not I won't say a bit cumbersome, but it's several steps, right? We take the data frame, we sort by a given column, and then we take ilog of 0. And you can imagine that this is a very common operation that we have to do. And since it's perhaps a very common operation, there might be already a built-in way to do this in Pandas. And there is. I can take a data frame, let's say output, and I can use the n-largest method. And I provide it a column, let's say ratio, and I provide it a number, let's say 5. And what this is going to do, it's going to give me the n largest rows that had the greatest value for ratio. I get a key error 5, and it's because I have it flipped, unfortunately. The first argument is how many you want. The second argument is the column to do the largest application. So there we go. Notice I didn't have to sort my entire data frame. I can simply use the n largest method. If I wanted 10, well, I say n largest 10. If I wanted the smallest, well, I use the n smallest instead.
That's weird.
So that means what I could do instead is I can say group by postcode, apply lambda df, df n largest 1 ratio. And I'll get the same answer. However, the peculiarity of this case here is that I have an additional column of postcode. That's a little weird, but this could have been the other way I could have solved it, using n largest instead. And the reason why this happens is that when you do the apply method, it keeps the index, and then it basically takes the result, and that are the additional columns for the data frame. So that is why we get an additional postcode column. It's a little funky looking. In fact, I can say something like just select postcode, BNF name, and ratio. I can do that instead, and I get a key error. Maybe I just say this. There we go. Let's try that. And I get another key error. All right. Perhaps I should read my error messages instead of reacting. Key error, BNF name, and ratio. Key error.
Oh, wow.
Let's see what happens if I say ratio here. That works out. I don't know why it complains when I say BNF name unless I am misspelling that. And it's called BNF name. I'll have to see what's going on there, unfortunately. I'm not going to sit here and debug it. Someone is giving me a suggestion, so let's try that instead. Double brackets. Yeah. That's, well, now I'm in the wrong cell. Yes, double brackets, of course. What was I thinking? And postcode is there twice. It's still there twice for some reason. That's annoying, why it appears twice. Yeah, list of lists. Yeah, that's what I needed to do. So that, now I'm able to get the BNF name, ratio, and postcode. I don't know, maybe it's a little peculiarity of pandas. I chalk it up to pandas having this weird behavior. Either way, let's just stick to this approach here because I think we have a better formatted answer. The list of lists should be inside the lambda, but I can do it outside afterwards. Yeah, I can do that instead and say, give me ratio, and BNF name. Let's see that. It's still there because it's an index. Actually, I'm going to try this. I'm going to reset index. Okay. Did that work out? That might have worked out. Let's see. Yeah, see, I'm going to call reset index. Okay, and then it complains because there's two columns the same name. But if I say reindex and I say post code, it's kind of messy. I'm not going to waste any more newer versions of pandas. Yeah, there's a newer version of pandas, so hopefully it has to fix that issue. But anyways, if I say result, I'm ready for the grader. And the best way to do this, the best way to format your results to the grader is go ahead and just select the rows of interest in the correct order we want them. So which is BNF name, and actually this is postcode, BNF name, and ratio. I get a key error because postcode is an index, so I can say reset index. And I want the top, and I should say sort values, correct? Sort values by ratio and say ascending equals false. And then I can say head of 100. I'm using head because head returns the first 5 results. So I can say ands, and that's the first, by default it returns the first 5 results, but I can say head 100, which gives me the first 100. And that should be the postcode with the BNF name and the ratio. I think that works out. And I think we called it items by region, so maybe it's best that I call that items by region instead. I'll call this items by region. And let's see what happens when I submit to the grader. Ooh, I get a bad score. I get a bad score. So I must have done something wrong. And let me think, what did I do wrong? Did I not merge practices unique? Maybe I didn't do that. Let's see. Let's see what it the merge. I did it with practices unique. Although I think it's a little let's see. Practices unique. Subset code, drop duplicates. Let me run that cell again. And my kernel has died, unfortunately. All right, kernel and restart and clear output. We sort by postal code. For some reason, I thought we had to sort by the ratio. All right, thank you, Gita. My faith in the answer as being correct has been restored. I was like, maybe I messed up somewhere up above. It helps to read the questions. Right, even though I do these office hours and I know the mini projects, I sometimes forget what exactly they want for the grader. Let's go in. Of course, this is all mismatch. I'll just comment that cell out. Then items by region. And I got to sort by postcode. So let me go back up above here and sort by postcode. And then do items by region. And what should have been the tip off, sort by postcode, and I want in alphabetical order. So I should not set ascending equals false. All right, I think that's a lot better because the top answer, notice the sample answer we give you, usually the sample answer is the first one in the series. So that should have been my tip off. Pass to the grader and I get a value of 1. All right, thank you, Gita, for saving me there, for pointing out that I should have sorted by postcode. But nonetheless, we got the correct answer. Let me know about any questions people have regarding this one. But we saw some cool things we can do in pandas. All right, so do let me know if there's any questions, but we'll continue to march on. And so far what we've done is we basically answered the first 3 or 4 questions of the last mini project. So Gita, you had the same issue, right? So I do appreciate that, yes, that you let me know what your mistake was, because I had the same mistake. Okay, so, but now let's do something different. Let's actually do something we haven't done so far in the previous mini project. And one of the things you want to do for the next question, or for the next set of questions, is we want to identify certain practices that have been prescribing opioids at a higher rate than normal. So you can imagine this is sort of a business problem, a business case, an actual case where we want to do this data analysis, is we want to look for practices, medical practices, that perhaps are filling out opioid prescriptions at a high rate. And the reason why we want to know this is because maybe we want to reduce the opioid abuse in our country, right? Maybe we want to curb that. So maybe the problem is maybe there's certain doctors, certain practices that are overprescribing opioids. Maybe the patient doesn't need those strong opioids, but they're prescribed and they get addicted, and that becomes a problem. Maybe there's some malpractice going on where people know if I go to this practice, the doctor is not following proper ethics and is willing to write opioid prescriptions for any small problem. And that's a problem because they're violating certain ethics, perhaps they're breaking certain laws. So what we want to do is we want to find the practices that are prescribing opioids at a very high rate, more than what is usual and typical. And maybe we can encapsulate this into a set of scripts, a function, so we can repeat this analysis on a different data set, perhaps a data set for the next quarter, for the next year, a different region, apply the analysis again and again for a different data set. So now we have the motivation of why this is important to do. Let's go ahead and look what we got to do for this question. So for this question is we've got to, under prescriptions, we need to, given the name of the drug, figure out if it's an opioid or not. And we're going to go ahead, for simplicity's sake, is that if a BNF name has any of these words in them, that's an opioid. That's what we're going to call an opioid. Any BNF name, any prescription that is filled out, and in the BNF name, it uses the word morphine or oxycodone or methadone, fentanyl, and so forth, that's an opioid. It doesn't need to be exactly morphine or oxycodone. It could be something like it could be morphine, 50 mLs or something like that. All it needs in the BNF name is to contain any of these strings. And if it does, we will say that is an opioid. So let's go ahead and run this cell here, this list of strings that refer to opioids. And now we have that chem data set. So let's examine that chem data set once again. And what we have here is a name and this chemical code. And this chemical code corresponds to the BNF code. So if I look at my prescriptions, my scripts data set, and I say head, examine that. Notice I have a BNF code. This code here corresponds to this chemical sub value. And here is the name of the drug. And I misspoke. I said it was the BNF name that we were curious to see whether it has any of those strings. It's actually this name field here. So in other words, if I take a prescription, I look at its BNF code, I use this other data set to look for its name, and if its name, anywhere in that name, contains any of these strings, that's an opioid. So if we devise our strategy, what we need to do here is we need to take this scripts data set right here, this scripts data set, and bring in this chem data set so that for every prescription, we know what its chemical name is. And once we bring in that field, then what we can do is we can look for every value of name and see whether it contains any of these strings. Because if it does, we're going to flag that as an opioid. So that is our strategy for right now. We want to flag every prescription. We want to know if it's an opioid. So if I were to sketch this out, and sometimes it helps to draw pictures, and I don't have my mouse here. So here's my trackpad, doing it with my trackpad. Here is my scripts data set. And I want to add a column with the chemical name. Given the BNF code, I can use that other data set to get the chemical name. And then once I have the chemical name for each prescription, then what I want to do is I want to add a new column. And this new column, I'm going to call it, I don't know, is opioid. And the value that is opioid would be true or false. So we want to flag every prescription if it's an opioid or if it's not an opioid. So that's my strategy right now. Let's get this data frame up and running. Any questions about our strategy here? So before we dive into the implementations, let's examine the chem data set. Let's examine this chem data set. And what I'm kind of curious to see is if there are any duplicates of chemical names. So I'm going to use shape, and shape returns how many records are in this data frame. So it's about 3,500. And if I say chem and I say chem sub and I say let's say n unique, so this returns to me the number of unique entries in this the number of unique values for a given column. And notice there appears to be a mismatch. A slight discrepancy. So there appears to be 6 rows that are duplicates. 6 rows that are duplicates. So we got to fix this. We got to fix this problem. And unfortunately, this is a subtlety in the mini project, which unless you fix, you might get to bad results. So we got to fix this problem. And just like we did before, we're going to do a simple strategy. We're going to drop duplicates and we're going to keep the first one. So I say chem, and I say sort values by chem sub. So in other words, we are alphabetically first chem sub code. Then we can call drop duplicates and say subset equals chem sub. And what is the strategy? Which one should we keep? We'll keep the first one. So keep the first alphabetically chem value. And I will call shape. And there we go. It looks like we fixed the issue. So now there's a unique, every record corresponds to a unique chem sub value. Kind of like we had with the poster code. I think the practice is having more than one poster code. We'll just sort it by chem sub, drop the duplicates that have the same chem sub. We'll keep the first one. Simple strategy. We've cleaned it up, and now we're ready to go. Okay, so it's 5:30 my time, so it's the end of office hours. So we'll have to pick this up next week as we continue working on this mini project. So hopefully we'll be done walking through the mini project, perhaps the middle of next week, so we can dive in and start working on, do some more interesting lectures about version control, about using argparse, Flask, working with web requests, all those nice things that aren't formally lectures, but are great to know to work on cool data science projects. So that is the overall agenda for the coming 3 weeks. Take care, guys. Have a good rest of your day. Have a good week, and have a good weekend, and see you on Monday. And take care.